lines and what we're going to call a transversal is the topic for today's video. Parallel lines are cut by what we call a transversal. To set this up, we're first going to introduce the fact that parallel lines are lines that go in the same direction forever and never meet because they go the same direction. Really, they have so much in common, it's a shame they never meet. Oh, a little romance for you there. Another important vocabulary word that you need to know going into this is congruent angles. Congruent angles are two angles that have the exact same measure. And parallel lines with an extra line that goes through them, the transversal, that's this diagonal line that goes through the lines, the parallel lines, are going to create many congruent angles. First, a bit of notation. Often to show lines are parallel, you will see us draw these arrows on the line. And if two lines have the same number of arrows, that's going to tell us that those lines are in fact parallel to each other. So the top line and bottom line are parallel. And then there's this third line that cuts into it. That third line that cuts into it through both lines is what we call the transversal. And what's nice about a transversal is it's going to make 8 angles, 4 obtuse and 4 acute. Turns out that the 4 acute angles, the 2 on top and the 2 on bottom, all will have the same measure. They will all be congruent. In addition, the 4 obtuse angles, all will have the same measure. All of them will be congruent. And often in geometry, we'll put curves inside of angles, and angles that have the same number of curves, that's a shorthand way to say they're congruent. So the obtuse angles with the double purple curve, those are all congruent to each other. They all have the same measure. The acute curves with a single green line, those are all the same. Those are all congruent to each other. This relationship gives us a lot of information if we're working with some examples. So in this first example, I've got a 156-degree angle. That's my obtuse angle. The obtuse angle we know is congruent to all the other obtuse angles. So the vertical angle across from it is also 156 degrees. The corresponding angle down below it is also 156 degrees. The opposite ulterior angle from it is also 156 degrees. Opposite exterior, sorry, wrong word. Opposite exterior. All the obtuse angles are congruent. They're all 156 degrees. In fact, we can even tell you what the acute angles measure because these angles are supplementary. 156 and the acute angle together made the straight line. So 156 minus 180 is going to be 24 degrees. So we know this acute angle underneath is 24. The vertical angle across from it is also 24 degrees. The alternate interior angle, the other acute one, is also 24 degrees. And the corresponding acute angle on the outside is also 24 degrees. Once I know one angle when we're dealing with these parallel lines, we know what all the other angles are. Here I have a second example again with parallel lines, but this time the angles are written algebraically. We've got a 3x minus 5 and a 2x plus 1. What we need to decide is how are these angles related to each other? Well, what you'll notice is they are both acute angles on the parallel lines. The lines have to be parallel, that's important, otherwise this doesn't work. But because they're both acute angles on the parallel line, they have to be congruent. That means they're equal to each other. So the 2x plus 1 has to be equal to the 3x minus 5. Those angles have to be equal. Well, we can solve this really quick, balancing on the equals. We'll move the x's to the right this time, subtracting 2x from both sides. And 1 equals x minus 5. So we add 5 to both sides, and we find out x is equal to just 6. Well, if the x is equal to 6, we can replace the x in either of these equations or expressions and figure out what it equals. So let's do that. 2x plus 1, or 2 times 6 plus 1, is that bottom angle. 12 plus 1 is 13. We have a 13-degree angle. all the acute angles then must be 13 degrees all the way up, because we have parallel lines cut by this transversal line. If we had plugged 6 into the top equation, or the top expression, 3x minus 5, 3 times 6 is 18, minus 5 is 13, we would have gotten the same result. So we can look at two parallel lines cut by a transversal and know the acute angles are congruent. The supplementary obtuse angles are also congruent. Or if we're dealing with an acute angle and an obtuse angle, one of each type, we know they're going to add up to 180 degrees. We can pull a lot of information out as we solve for various angles. Here's a really great puzzle. We have these two parallel lines, and they should be marked with arrows. And we want to find out what w, x, y, and z are. This might be a little tricky. What we're looking for is relationships on the parallel lines. So first, I'm just going to pay attention to this line. I'm going to highlight the right line, ignoring the other line. If I just pay attention to that line, what I see is I've got this 77-degree angle, and y is also an acute angle on that same line, on that same parallel line. Those acute angles have to be congruent, so y must be 77 degrees. Z is right next to that 77-degree angle. So z has to be the supplement. They have to add to 180 degrees. So if I do 180 minus 77, I'm going to get 103 degrees. Z must be 103 degrees. What else do we know? Well, we might have to get a little bit creative to get our next angle. But here's what I would do. If I'm just looking at the yellow line, there's this obtuse angle that connects the yellow line to the parallel line. That covers both the 34 and the w. That's the supplement. We just found out that entire distance is 103 degrees. So, if that's 103 degrees, it's made up of a 34 and a w. In other words, 103 minus 34 is 69. There are 69 degrees left over. This w is 69 degrees. Now we still need to find the x, and you notice the x is located exclusively on the other line. I'm going to highlight it in orange. So for now, we're going to ignore the yellow line and see if just focusing on the orange line, we can find angles that are formed that will be useful to us. And sure enough, the acute angle 34 is in the exact same relationship with the parallel lines as the x. In other words, those angles are congruent, and we have a 34-degree angle. In fact, if we wanted to get really crazy, we could fill in all of our angles now. We know the bottom one's 34. The supplement to 34 is going to be 146. We know the 77 is a vertical angle with the one above it. 34 is a vertical angle with the one across from it. 69 is a vertical angle with the one across from it. 77 is a vertical angle with the one across from it. And the 103 is a vertical angle with the one across from it. So as you can see, once we start to fill in some angles with what we know and what relationships we see, we quickly can find all of the angles on these parallel lines. Sometimes it takes a little thinking and creativeness. Sometimes I have to highlight one line and ignore another line. But when we see those relationships that make up the angles, we can find all the missing values. Take a look at the homework assignment, working with parallel lines and transversals, and let your instructor know if you have any questions. Good luck.